So now let's talk about functions. Functions is a key topic, not only for this course, but in every course from here on out. What you're going to really be talking about are functions. And functions are a special type of relation, so a connection between an input and an output. A special type of relation where every input is paired with exactly one output. Okay? So no x values can repeat. So for these next problems, let's determine if the relation is a function, and then let's explain. And then we can identify the domain and range. So first off, let's just say, is it a function? Is it a function? So we look at the x values, because those cannot repeat. They can only be connected to one output. So 1 is connected to -4, 0 is connected to 2, -5 is connected to -4, and 1 is connected to 3. We have a red flag come up here because we see 1 is connected to -4 and 1 is connected to 3. So 1 is connected to two different outputs. That doesn't work. So is this a function? No. 1 repeats. Okay? So since 1 repeats, since we have a member of the domain that repeats, this is not a function. This is just a relation. Okay, but we can still identify what's the domain, what's the range. Domain is the list of all the x coordinates, all the inputs, 1, 0, -5, and 1. Typically, we would write those in ascending order, so I'm actually going to rewrite this. I go -5, 0, and 1. And then I don't need to write 1 twice because I've already got it considered when I have that domain value of 1. All right, so I don't need to write 1, 1. Range, the lowest output we have is -4, and then we have a 2, and then we have a 3. Notice how I did not say -4 twice. I don't need to. And it doesn't matter that we had a member of the range repeat. That's fine, because 1 goes to -4 and -5 goes to -4. So a range value repeats, but the domain does not for those coordinates, okay? But we do have the 1 repeating. We have the 1 going to two different outputs, which is a no-go. So next up, let's do B. Let's look at the x coordinates. Let's see if any of them repeat. -2, -1, 0, 1, 2. None of those repeat. So is this a function? Yes. No x values repeat. So let's list the domain and the range. So domain, we have -2, -1, 0, 1, and 2. For the range, our lowest output is 1. And then we have a 2 that repeats. And then we have a 4 that repeats. Okay? Again, it's okay if a range value repeats. That's fine. But an x value cannot. So pause the video here. Now that we've talked about functions, try C and D. And I'll throw up the answers in one quick second. So pause the video and try those two problems. Alrighty, so check that out. See if you have any questions on C and D. Make sure your work matches mine. Okay. So last thing we're going to talk about in this video is the vertical line test. So the vertical line test is used to determine whether or not a graph represents a function. So in these above examples, we had ordered pairs, tables, and a mapping, but we didn't have any graphs. So what is a quick and easy way to determine whether or not a graph represents a function? So if I can draw a vertical line anywhere on my graph, if it intersects it more than once, it's not a function. And we'll talk about why in a quick second. But if we go to A, if I draw a vertical line anywhere on this graph, it is only going to intersect it at most once. So is this a function? Yes, it is. All right, what about b? So if I draw a vertical line here, only intersects once, here only intersects once, but if I draw a line here, notice how it intersects the graph 3 times. All right, so no, this isn't one because it fails the vertical line test. All right, and the reason that we know that this fails, that this is not a function, is that means that this input of -2 gets mapped up here, here, and down here. So -2, that domain value is repeating 3 different times. Okay, same thing over here. Like if I draw a vertical line through 3, that intersects it once, twice, 3 times. So that input of 3 goes to 3 different outputs. So that input value repeats, and that's no good, okay? What about in C? So C is a weird looking graph, all right? So if I started drawing vertical lines, you might think right here we're going to have an issue. Or right here we're going to have an issue because it goes through what looks like 2 points. All right, but notice how we have an open circle here and an open circle there. Open circle, think about when we are graphing inequalities, means that it's not included. So the vertical line actually doesn't go through that open circle, but it goes through this closed circle. So that only intersects once. This vertical line goes through this closed circle, but does not go through that open circle. Okay, so yes, it passes the vertical line test. So open circle, not included, closed circle, included. Okay? So that is how we can determine whether or not a relation, no matter its representation, whether or not it's a function or not. All right, in the next video, we will introduce the concept of interval notation.